Hey guys, Ms. Peterson here, and welcome to our chemistry lecture on covalent compounds. In this lecture, we're going to be going over how covalent compounds form, how we name those compounds, and some of their properties. Okay, so let's get started. What is a covalent bond? Well, a covalent bond is a bond in which the atoms share a pair of valence electrons. And we can see that in the word, okay? Co means together, and valent refers to those valence electrons. Okay, so covalent is shared valence electrons. Now, this will always happen between a nonmetal and another nonmetal. Okay, so these are ones like carbon, hydrogen, oxygen, and nitrogen. Okay, they'll have the smaller differences in electronegativities, which won't allow one atom to completely steal the electron, like in an ionic bond. There are three types of covalent bonds. There's a single bond in which they share one pair of electrons. So that's important to note. A single bond isn't just one electron being shared, it's a shared pair of electrons. Then there's a double bond where there's two shared pairs, and a triple bond where there are three shared pairs of electrons. And the triple bonds are going to be the strongest because you're going to have the most attraction, the most charge there. Okay? So, just a reminder, again, it is these elements that will form a covalent bond. The noble gases of group 18 don't really bond. So really, we're looking at carbon, nitrogen, oxygen, the halogens, phosphorus, and sulfur will be the elements that are involved in our covalent bonds. Okay. Oh, and hydrogen. You can't forget that hydrogen is a non-metal. Okay. So how do these covalent bonds form? Well, just like in ionic, where they form ions so that they have those stable 8 valence electrons, same with covalent. 8 is still the magic number. 8 is still that stable outer shell where atoms are going to be at their lowest energy state and most content. Okay? So they will share until each atom has 8 valence electrons. Except for hydrogen, hydrogen will only ever have 2 valence electrons, which makes sense because if we remember, hydrogen just has one energy level that can only fit 2 electrons. Yeah. Now, when sharing, each atom will donate one of its unpaired electrons to create the shared pair. Okay, so let's look at an example of this. Okay, we said hydrogen only has one valence electron. Okay, it's in group 1. And then let's look at fluorine. Okay, fluorine has 7 valence electrons. Okay, 1, 2, 3, 4, 5, 6, 7. So what happens when they bond is this pair becomes a shared pair. So hydrofluoric acid can be represented as HF. Okay, and sometimes you'll see it represented like that. Sometimes this shared pair becomes a line and is that covalent bond. Okay? Let's look at one like water, H2O. Okay? So, we still got our 2 hydrogens now. Okay? I'm going to do one there and one there. And then we have oxygen. How many valence electrons does oxygen have? It's in group 16, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. So you can see oxygen has 2 unshared pairs. So oxygen really likes to form 2 bonds. Okay, that will form a shared pair, and that will form a shared pair, making our molecule of water have a structure where oxygen has 8 valence electrons around it. The hydrogens each have 2, so everybody's happy. And we can also rewrite it with the lines instead of the shared pair. Now, these representations are called Lewis structures, and we'll be learning how to draw those in our next lecture. Okay? But what do we call ionic compounds? Okay? We're going to need these list of prefixes. And because covalent compounds can form with different numbers, it's not like ionic where there's always going to be a set ratio. Okay? The prefix indicates the number of atoms of that element. Okay? So we use the first element using its elemental name, just like ionic. And then we do the second element using its elemental name, but changing the N to IDE, just like in ionic. But the only difference is in covalent bonds, we use prefixes to denote the number of atoms, okay? Except if it's mono, we omit it for the first element. So like you guys have seen CO2 before, okay? There's only one carbon. So if it's the first element, you just use its name, carbon, and then there's 2 oxygens. So the prefix for 2 is di. So di, and then it's oxygen, oxide. Okay, carbon dioxide. Where what would CCl4 be called? Well, we have that carbon again. And then we have 4 chlorines. 4 is tetra, okay? Like Tetris. Did you notice that all of the Tetris blocks are always 4 blocks? Okay, tetra is 4. So it's carbotetrachloride. Okay, let's try a hard one. What would this one be? N2O5. So if we have more than one of that first element, we do use a prefix. So we have dinitrogen. And then 5 is penta. So dinitrogen pentaoxide. Might be pentoxide. Close enough. I don't know if that is in there. That's just a spelling thing. You guys get the general idea. Okay, cool. Okay, cool. So some of the properties of covalent compounds, because that shared pair of electrons isn't a complete charge, okay, it's going to be slightly weaker than ionic compounds. So they are generally liquids and gases at room temperature. They're small molecules. They don't stick together a lot to form those solids, okay? They just float around, okay? They do not conduct electricity. There's no free ions to move, and they have relatively low melting and boiling points. They don't have all of that lattice structure of the ions. They're just little molecules, okay? Now, we do have to be aware that there's also the macromolecules that are covalent, okay? These are things like plastics or carbohydrates or polymers, all of these big ones, and granted, plastics and carbohydrates are a subset of polymers. But for those ones, they are going to have different properties because they're just made of thousands and thousands of atoms, okay? They're made of repeating units called monomers, and this includes proteins and carbs and plastics and all of those. These are generally solids at room temperature, okay? They are large molecules, but they still have the same general properties of covalent ones, okay? Now, one more thing we need to talk about when we talk about covalent compounds, and that is a polar covalent bond. So there's 2 types of sharing in a covalent bond. There's unequal sharing, which is the polar bond, okay? This will happen when you'll have a partial positive and a partial negative part of the molecule, okay? The electrons are not shared equally. Where there's equal sharing, which is nonpolar, okay? In unequal sharing, one atom will pull on the electron more. In a nonpolar bond, the electrons will stay right in the middle. The polar bond will happen when you have bigger differences in electronegativity. So anytime really you have different atoms, where a nonpolar bond is when you have the same atoms in the compound, okay? Or carbon-hydrogen bonds actually are also nonpolar, okay? So water is a great example of a polar compound. Because of its bent structure, you're going to have a little bit negative, okay? We use this sign for partial negative on the top, and you're going to have a little bit of positive down by those hydrogens, okay? Because you're going to have more electrons by the oxygen. Where methane, CH4, is supersymmetrical and only made of carbon-hydrogen bonds. So it is a completely nonpolar compound. Fluorine and fluorine, you got 2 of the same atoms. They're going to pull on the electrons the same amount. Okay? You're not going to have one being hogging more than another. Okay? And this will lead to how they interact with other molecules. So like polar compounds tend to interact with other polar compounds more than nonpolar compounds, and so on and so forth. Okay? But that's it for covalent compounds. Okay, cool? Okay, cool.